Hello everyone. Today we're going to go through LeetCode problem number 94, which is binary tree in-order traversal. So if we look at LeetCode, it's saying given the root of a binary tree, return the in-order traversal of its nodes' values. Now what does that mean? Let's dive into that a little bit deeper. So what is in-order traversal? It's also known as left, root, right, meaning we're going to go through the left branch, we'll take the root, and then we'll go through the right branch. Left side, so we're going to go all the way down the left branch and look at the subtrees, find the leftmost branch, which doesn't have any branches underneath it. We're going to grab that number and work our way back up the tree from left to right. We'll continue that until we hit the root, and now we need to go down the right side. Find the first subtree without a left node, which will be the 6. And then grab the number and work your way back up. Okay, so a picture is worth 1,000 words here. Let's go through another example, more in-depth. So we'll start here at the root node, and we'll go down the left side and grab the 5 first. Because there are no branches underneath the 5, we'll go back and grab the 15 and then grab the 18. We're done here, so we go back up to the 20 and then grab the 25. Then we go back to the root node. And now we go down the right side of the tree, but we're looking for left branches still. So we'll grab the 35, bounce back and grab the 40, then go down to the 50 and grab the 45 first. Then we back up, grab the 50, and finally grab the 60. So let's go back to LeetCode and see if we can understand these examples. So the first example, the input is 1, null, 2, 3. So it's 1 is the root, but because there are no left branches, it marks it as null. And then we go down the right side and grab the first left branch, which is 3, and then grab the 2. So that's why the answer is 1, 3, 2. In the second example, it's just nothing. There's nothing there. Third example, there's just one node. So we'll just put that in there. In the fourth example, we're given 1, 2. We're going to return 2, 1. Left branch, and then the root. In the fifth example, is 1 null because there's no left branch. And 2. So we'll grab the root node first and then grab the 2. Okay, so how are we going to do this? All right, so we're going to use what's called a stack, which is last in, first out, LIFO. And we're going to put the result into a new variable. So the first thing we're going to do is we start at the top and we push 1 into the stack. And we go down the left side, so we push the 2, and then we push the 4. But because we don't have another left node, well, now we're going to pull that off the stack and put it into the array. And then we'll grab the 2 and put that in array, and then we'll go down the right side and pull the 5 off. Then we'll go back up the tree, pop the 5 off, because it doesn't have any more branches underneath it. And then we'll go back to the root node and pop that off. Now we'll go down to the 3, we'll push that on the stack, and go down to the 6. The 6 doesn't have a left or a right node, so we'll pop that off. And finally, the only thing left is the 3, so we'll pop that off. And that is pretty much the logic that we're going to use. So let's try and figure that out. All right. This is the method LeetCode gives us and passes in the binary tree. So the first thing we're going to do is define the result as a list of integers to store the output, and we'll define that stack as a stack of tree nodes. All right, so while root is not equal to null and stack is not empty, so we need to make sure both of these are satisfied, because we could have a null root, but the stack could still have a value, which actually will be the case with this 3. there won't be any values left, but this 3 will still be in the stack. So first we only care about the root not being null. So we're going to push the value onto the stack. So the first thing we'll do is push that 1 on the stack like we saw. Then we'll assign the root equal to root left, which will assign this to the 2. Okay, so this is going to build the left side of the tree. It's going to find the leftmost node. So root left of 2 will be 4. And 4, so now we have in the stack, we have 1, 2, and 4. But when we get past the 4 and try and assign root equal root left, this will end up being null. And so then we're going to break out of this internal while loop, and we need to pop that number off of the stack and add that to the result. So we're going to add the 4, and then we assign root equal to root right. Okay, so if we do that, 4 doesn't have a right. So we'll end up, well, root is not equal to null, it will be null. So then we will pop off the 2 and add that to the result. And because root right, 2 has a right, it will then do the 5. But anyway, we'll go through the debugger and it should make more sense. All right, so I'm going to put up a little graph here that I've been using the whole time. All right, so we define the array list, we define the stack, while root is not equal to null, which it isn't, it's equal to 1. So we're going to push the 1 onto the stack. So we look at the stack size, position 0 is value 1, and you see it has a left and a right. The 1 has a left and a right. We assign the root equal to root left, which is 2, push that onto the stack, and finally push the 4. Okay, so now the root left is null. So now we're going to pop the 4 off the stack and add it to the result. So if you look at size 1, it has a 4. And assign it to right. So right is null. So it's going to skip this whole while loop and pop off the 2 and add that to the result. Now 2 has a root right. So now the root is not null. So now we're going to, this is kind of funny, we're going to push the 5 onto the stack and assign root equal root left, which will be null, and then now the root is null, so now we're going to pop the 5 right off the stack. So we're still working with pushing and popping, so we need to do that. But anyway, so now the result is size 3, 4, 2, 5. And root is root right. Okay, so 5 doesn't have a right, so we're going to pop off. So that should have been the 1. Where's the result? I'll grab it next time. I can do it up here. Yeah, 4, 2, 5, 1. All right, so now we're going to go down the right side. And root left, 3 has a root left, which is 6. Okay, so now we're popping off the 6, adding that, root equals root right. Now there is no value, there is no root right, but the stack is not, we still have that 3 in the stack. So we just pop that off, add it to the result, and now if we look at the result, 4, 2, 5, 1, 6, 3. So that is in-order traversal of that binary tree. All right. So the only thing we have left now is the time and space complexity. So time complexity is O of n. Basically just depends on the size of the tree. The bigger the tree, the more time it's going to take. And space complexity is also O of n, depending on the size of that tree. All right, hopefully you have a good grasp, or better grasp, of binary trees and traversing them. Hopefully this video was helpful. Let me know anything I can improve, and as always, thank you for watching.